Okay guys, I said I'd work a few from the assignment for tonight, and also you can go to Desmos at home and kind of play around with some of these, especially in the last section. So let me just get you started. Number one is really saying g of x times k of x, like that. So g of x is x squared, k of x is the square root of x, and this looks kind of weird, but I can do a little bit more with this. So I'm going to rewrite x squared and then multiplied by x to the 1/2, because the square root of x really is x to the 1/2. And now I can add these exponents, and I would rewrite 2 as 4 over 2, because 4 divided by 2 is still 2, and I would need a common denominator, so I'm going to say 4 over 2 plus 1 over 2, and I'm going to get x to the 5/2. So that would be the answer for number one. So it's kind of an interesting little problem. Then just kind of jumping around, for number 3, I'm going to have g of x minus h of x, and g is going to be the function x squared minus, and then anytime you subtract, you especially want to use parentheses here, so I'm going to have x minus 8. And then I always want to think of this as either distributing a -1 or adding opposite signs or opposite values. So I'm going to change the signs inside there. Okay? So then I'm going to have, this should have been g, which is x squared, minus x plus 8. So it's going to be x squared minus x plus 8. Okay, so this whole top section is all about just basically operations on the functions. Number 6 is one that I do want to go over with you. It's really f of x divided by g of x. And then f of x is 1 over 2x. Now, this time I may write this a little bit differently because I have a fraction here, so it's kind of a new little scenario there. So I'm going to say 1 over 2x divided by my g function, which is x squared. So I'll write this like this. So then this is going to be a reminder that I can really do 1 over 2x times the reciprocal like this. And then that would be x squared in the denominator. So I'm going to get 1 over 2x cubed. And where I got the cube from was the 1 here and then the 2 there. Those get added together. Now, I also need to make sure that in the original function, the denominator cannot equal 0. So I need to go back and I need to look at g of x. I need to set that equal to 0. And I need to say that it can't equal 0. So I'm going to kind of take this little extra step up here. So I'm going to say x squared cannot equal 0. And then I would just take the square root of both sides, and x cannot equal 0. So x cannot equal 0, and that is your answer for number 6. So that was one of the harder ones, so I wanted to do that with you. Now the whole next section, 7 through 12, is all about plugging in an x, evaluating the k function at 9, for example, and then plugging that into g. So let me just do one of these for you. So first I want to find k of 9. So k of 9, I'm going to go up to my k function. It's just the square root of x. So it's the square root of 9, which is 3. Then, instead of k of 9, I'm going to plug in the 3. So now I'm going to do g of 3. So go to where it says g, and then it's just going to be 3 squared, which is 9. Okay? So the answer is 9. And some of you may be saying, well, wait, what just happened? It is because if you took the k function, which is the square root, and you plug it in to the x squared function, it simplifies all the way down to x. So that's why when you plug in an x of 9, you get out a 9. So that's kind of what's going on with that one. But you still just do it the same way. So let me do another one. I'm just kind of looking around. Let's go ahead and do number 12. So I'm going to take my h function, I'm going to plug in 1. So h of 1 is just going to be 1 minus 8, which is -7. So instead of h of 1, I'm actually going to plug in a -7 into the f function. And then my f function is 1 over 2x. So I'm going to plug in a -7 there, and I'm going to get -1/14. That is my answer there. So this whole second section here, number 7 through 12, you are going to actually get a number out when you do this. Now, this bottom section is when we're doing our compositions, where we're taking one function and plugging it into another function, but we're adding something new where you have to state the domain, okay? So let's look at, I'm going to pick one that, let's look at number 18. Now 18 has the input function of h, which is a square root. So it does have domain restrictions. So I'm going to have to think about that, okay? So I know that whenever I take the square root of something, it has to be either 0 or positive to take the square root of it. So what is underneath the radical right there, the x minus 3, has to be greater than or equal to 0. Now I want to make sure you really understand why I would say that. Because when I take the square root of 0, it's 0. Square root of 1 is 1. Square root of 4 is 2. But I cannot take the square root of a negative and get something that I can graph because I get an imaginary answer. So when I solve for this, I'm going to say x must be, just adding 3 to both sides, I'm going to say x must be greater than or equal to 3. Because if I plug in a 3, 3 minus 3 is 0, I can take the square root of it. If I plug in a 4, 4 minus 3 is 1, I can take the square root of it. So this is my domain restriction for my input function. That means it's going to be my domain restriction for the whole thing, okay? So then let's go to k, and k is x squared plus 2, but I'm going to plug in the h function, which is going to be the square root of x minus 3, okay? So now, you guys remember that when you square the square root, they cancel each other out. So I just end up with x minus 3 plus 2, which is just going to be x minus 1. And I know my domain is x greater than or equal to 3. So this is my answer. So I have my new function. It's just a line, and it's x greater than or equal to 3. So I'm going to actually do this on Desmos with you guys so you can kind of see what this looks like. And let's see, get another. Okay, so you want to play around with Desmos tonight anyway. And I am going to go ahead and input my two functions. So when you get to Desmos, just say start graphing, and it takes you right in. And I'm going to say h of x is equal to, and I'm going to say that that is the square root of x minus 3. So you can see the function, and you can see here how the domain is restricted. Your x's must be greater than or equal to 3. So you can see the domain there. Then I need to do my next function, which is my k function. And my k function is simply x squared plus 2. So I'm going to have x squared plus 2. Okay? And it is a quadratic for that one. Okay? So it has no domain restrictions on it, but the red function, which is going into the blue function, does. So now I'm going to say k, and I'm going to say input h like this, like so. Not like that, but like that. Now, do you see the resulting green line? That is what we had from before, which is x minus 1, but it's only valid where your x's are greater than or equal to 3. So if I travel down using my slope, I'd end up here, here, I'd end up here. So this would be my line right through here. Okay, in fact, let me graph it. I know it's going to be a line at x minus 1, and there you go. So you see how it's restricted because the original function was restricted. So that is what we're doing today. So make sure on that whole bottom section you ask yourself what the restriction is for the original domain.